Hello everyone. Today's session is going to be about summation of numbers, specifically summing up numbers from 1 to n, that is 1 plus 2 plus 3 till n. As you all already must be aware, this is nothing but n into n plus 1, the whole thing divided by 2. Which means, let's say if I'm adding numbers from 1 to 5, that is going to be n, right? 5 into n plus 1, which is 6, divided by 2, which is 15. So we understand what the formula is. Before we move away, let's understand how this formula comes about and whether that is useful in understanding other mathematical concepts. So if you're adding numbers from 1 to n, isn't it the same as adding numbers, let's say, from n to 1? So I'm adding n and then n minus 1 and n minus 2 till we are left with 2 plus 1, right? Now let's pair these numbers and add them. So let's add 1 and n, right? That gives us n plus 1. If you add 2 and n minus 1, again that gives you n plus 1. You add 3 and n minus 2, surprise, again that gives you n plus 1. So each of these pairs all the time will give you n plus 1, right? So if you add the two series together, you get n pairs, each adding up to n plus 1. Now this is the sum of two such series. The sum of one of them means just divide by 2, right? Now the sum being n plus 1 all the time is not very surprising because your 1 to 3, this series increases by 1 all the time, right? And your n and n minus 1, the series at the bottom, decreases by 1 at the same time. So the increase in 1 and the decrease in 1 cancel each other, and the sum continues to be n plus 1 for each of the pairs. Now, where is this helpful? If you recall, you have an arithmetic progression starting from a, then a plus d, a plus 2d, right? If I have to sum up till the nth term of an arithmetic progression is a plus n minus 1 d, right? Because your arithmetic progression has the same difference between two consecutive terms. So a and a plus d, the difference is d. A plus d and a plus 2d, the difference is d, right? So your nth term means you're adding d n minus 1 times. Now, if I add the series in reverse and I pair them the way I was pairing in the 1 to n series, right? You can see that the sum will always be 2 plus n minus 1d, right? And the number of terms are n. So you just divide the whole thing by 2. So your arithmetic progression summation formula also comes from here, right? So now let's put all this into action, right? We know that summation 1 to n, which is also written as, this is the summation sign of k, where k goes from 1 to n, right? So using this, let's try and find out what is the sum of, let's say, numbers from 4, 5, 6 till n. I would suggest that you pause the video and think about how you would find the sum of these numbers. Great. Now, one way in which you can find the sum of these numbers is to see this as a series from 1 to n, from which the first three terms are subtracted, right? 1, 2, and 3 are subtracted. So you can write this as summation 1 to n, right? And from this, we need to just subtract summation 1 to 3. This is one way of looking at it, right? The second way of looking at it is that each term, 4, 5, 6, each of them are basically 3 added to your basic series, right? So 4 is nothing but 1 plus 3, 5 is nothing but 2 plus 3, right? Similarly, n is nothing but n minus 3 plus 3. So this is the summation of numbers from 1 to n minus 3, and 3 is added to each of the numbers. I need to add this 3 n minus 3 times because there are n minus 3 numbers, right? Third way in which we could do it is using this, the arithmetic progression concept, right? That your sum is going to be the number of numbers, which are n minus 3, into the first term, which is 4, plus the last term, which is n, the whole thing divided by 2. So you see how effective this method is, right? When you think of the sum as the number of numbers, right? Into the first plus last term divided by 2, right? Then you can see the summation expression straight away. Here, in the first and the second example, before you can do any arithmetic, you have to first do the algebra and try and express this in terms of n. Whereas the third straight away gives you an expression in n, right? So now you understand how this formula works. Let's see some questions based on this in the CAT.